All right, good morning, and welcome to another test prep time with Method Test Prep. Again, my name is Kevin Dennis. I'm actually the director of law and classes with Method Test Prep. So I'm here just to talk to you about again another concept that some students might have an issue with. Specifically, going to talk about percentages and percentage increase and decrease. These questions have a tendency to throw students off because they just misread the questions and misapproach them. So, going to kind of go over a way of trying to just make these just a little bit simpler for students. So, again, as usual, I just want to get a quick little plug in. I do want to talk about just a couple of the quick services that we do provide. I'll be talking at the end as well. We do provide, in our day of Corona, we do provide SAT and ACT tutoring online, as well as tutoring for all subjects as well. You can certainly just go to our website, www.methodtestprep.com/online-tutoring, and we can kind of go over, how the online tutoring works. And again, SAT, ACT, the next one is expected to run June 13th. And again, any subject that students may need help with, we can certainly help out as well. So the first thing I'm going to talk about is simply just talking about just a couple of quick definitions that are really important to know when it comes to percentages. So obviously, what is it? The definition of a percentage? It's basically a part of a whole, and it's expressed specifically in hundredths. So a formula. So if I want to kind of put that in mathematically, that's going to be basically part over whole. So it's the part that we're dealing with over the whole, the original amount, times 100. One thing to keep in mind, whenever I refer to percent of, again, you always want to think of as always referring to multiplication. A lot of students, when they see the word of in a word problem, they immediately think of division, often because of percentages, because they're thinking of the term is over of. So they think of then because that's the denominator refers to division. But if I say percent of something, of is always going to refer to multiplication. So kind of keep that in mind. Another thing I'm going to be talking about is decimalization, is how I turn a percent into a decimal. Because generally speaking, it's a lot easier to work with percentages once you turn it into a decimal. And there's two main ways to do that. You can take that percentage and divide it by 100, or you can move the decimal point 2 spots to the left, 2 digits to the left, whichever is easier. I think, generally speaking, especially if you have access and use of a calculator, I think it's easier to use the first one to divide the percentage by 100. We'll be seeing a question in a little bit where that kind of comes into play a little bit. But seriously, whatever works easier for you is going to be helpful. Okay, so let's take a look at our first problem to see how we can kind of work with a relatively basic percentage question. So with this one, we have a performer. He earns $120, okay, and he uses 43% of the money involved in putting on the performance. The rest of the money is what is profit. So it costs him 43%. The rest is his profit. Now, this question is now asking what is the profit the performer makes at a performance, even though the question with the numbers they're giving us is saying that it's 43% of the costs. So that's going to be an interesting play here because really 43% isn't really what we're looking for. We're looking for something different from that. And that's actually this question is going to be a nice little segue into how we're going to handle some of the more difficult questions that you'll see on the SAT or ACT. But let's just start with this basic one. So again, it's 43%. So again, we want to think of how we want to decimalize that percentage. So again, we start with 43%. So again, there's the two ways we can decimalize it. I can take that 43% and I can divide it by 100. And if I take 43% and I divide it by 100, I'm going to get 0.43 or 0.43. Again, another way of doing it, I can take that 43 and then I can then just move the decimal spot 2 spots to the left or 2 digits to the left. And again, it's the same thing. By moving that decimal 2 spots to the left, I'm still going to get 0.43. Again, whichever is easier. Again, as usual, I do think it is easier to put in the calculator, dividing it by 100. I think that less likely where students will make a mistake. But again, whatever you're most familiar with. So since we're dealing with the 43%, and again, we're doing percent of, I'm going to be taking that 43% in this case that I have now decimalized as 0.43, and I'm going to multiply that by 120. Once I take that 0.43 and I multiply it by 120, I'm going to get 5160. Now, this is a very stereotypical question where you actually see 5160 as part of the work, and look how 5160 is one of the answer choices. So again, it's very important with all these exams to make sure you're answering the question that's being asked. That sounds very straightforward. However, it is very tricky sometimes with some of these questions how they're going to ask something just one little twist, and one little twist unfortunately, even though students did everything perfect, because of that choice, they still get the question wrong. So again, we're not looking for 5160 because we're not looking for the costs. We're looking for the profit. So that's going to be the rest of it. So what I would then have to do is take that $120 and then subtract that 5160, because again, there are only two components here, the 5160 being the cost and then the remainder being the profit. So we take that 120, so me actually going to give me the correct answer, which is 6840. So I take 120 minus the cost of 5160, which was the 43%, which then gives me the 6840, which is the correct answer. Now, one thing to keep in mind is another way to approach this question. And either one is going to work. I think the math is about the same. But one thing that's really important to understand, and this is going to help us with some later questions, is that 100% is always equal to 1. Again, if I think about the decimalization of 100%, if I take 100 and divide it by 100, I get 1. If I take 100 and move the decimal 2 spots to the left, 2 digits to the left, then I'm going to get 1. And keeping that in mind is going to be extremely helpful when we get to some other questions where they do get a little bit trickier, where they do have a lot more multiple steps. Because of this question, what I can do is that instead of doing the subtraction afterwards, I could do the subtraction in the beginning. So I could take that 100% and subtract the 43%, which again, that would be the same thing as taking the 1 and subtracting the 0.43. Either way, I'm still going to get the same thing. I'm going to get 57% or 0.57. So by doing the subtraction ahead of time, I can then still now the 57%, instead of figuring out the cost, I'm now figuring out the profit from the get-go, right from the beginning. And again, I'm going to do the same thing. I'm going to take the $120, multiply it, because again, it's percentage of, so it's multiplication, times the 0.57. And again, yet again, I get the 6840, which again still gives me the correct answer. So we're going to put that into play. So now we're going to go into our next question. So I have example number 2. Teddy was helping Midtown run his food drive. There was 240 cans of corn. And then he's been told there was an 125% increase in cans of corn. So how many cans of corn did the Midtown East Fire Department have on April 8th? Okay. Well, again, it's going to be 125%. So what I'm going to do is I'm now going to take that and I'm going to divide it by 100 to get my decimalization. Or again, move the decimal spot 2 spots to the left. And I'm going to get 1.25. So again, the decimalization of 125% is 1.25. And this is a perfect example of why I think using the calculator is better, because a lot of times students will simply want to take that decimal and put it right in the beginning, and that's not always the case. That's why you have to be specific. You're moving the decimal 2 spots to the left. So by moving the decimal, that's after the 5, 2 spots to the left, 2 digits to the left, I get 1.25. But again, because the tendency is for students just to put the decimal at the beginning, I think it's usually easier just to take that number and divide it by 100 so you don't make that mistake. So in this case, we'll say that C is going to be equal to cans of corn. And because we have the cans of corn, what we're going to do is we're going to take that 125% of the original amount. Again, so that's multiplication to get my new amount. So I'm adding it, the 125% to the original amount to get the new amount. And this is where these can get a little tricky, because I'm not just taking the 125% times that amount, I also have to then add it to the original amount. So if I want to put that algebraically, what I'm going to do is I'm going to take the cans of corn, which I'm representing with the variable C, and then I'm going to add 1.25 times C. So I'm taking 125%, aka otherwise written as 1.25 C, which will then give me the new amount. But again, I need to add that to the original amount to find out what the total is. And that's, again, something that students have a tendency to forget. You take the original amount and then add that new percentage. So by taking the original amount, which I know is 240, I'm going to add 125%, in this case, again, which I've decimalized as 1.25 of the 240. So again, algebraically, mathematically, this is going to be represented as 240 plus 1.25 times 240. And what I'm going to end up with now is 540. So that's going to be my new amount. So again, starting with 240, I'm increasing it, so that gives me the add 125%, it gives me the 1.25, times percentage of multiplication, again, that original amount, which then gives me the 240, which then gives me the new amount of 540. Now, the thing about percentages where a lot of students will make mistakes, and again, when you get to some of the trickier questions, especially on these exams, because one thing these exams love to do is to do things backwards, okay? So percentages are always based on the original amount, okay, like we just saw there. So, but a lot of times they're going to do questions where they do it on the new amount and you need to go back to the original, which we're going to talk about in a little bit. But let's start with just the one that we had just done. So because it's always based on the original amount, percentage increase, a relatively straightforward and far more simplistic way of handling this question, would just be to add the decimalized percentage to 1 and multiply. So we're going to put that in play in a couple seconds, but let's just think about this for a second. So by the decimalized percentage, I'm adding to 1. Now why am I adding that to 1? Because again, 1 is 100%. The decimalized percentage is now that percentage I'm now adding to 1. I'm going to multiply because, again, I'm going from the original to the new. So let's look at the question that we had just done. So again, a far more simplistic way of handling this question, instead of doing all this algebra by taking that original amount and then adding 125% times that original amount, what I can now do is, if I look at this problem, notice how the coefficient, the number before the c, is technically going to be 1. So what I have here is I have 1 amount of cans of corn plus 1.25 of the amount of cans of corn. So basically I have 100% of the cans of corn plus the 125% of the cans of corn. Again, 100% being 1, 125% being 1.25. So if I look at this now, if I notice 125% again is the 1.25, one thing I could do is I'm taking 125% plus 100% of the cans of corn. Again, that's the same thing as 1.25 plus 1. Okay, so again, the 125% is the increase, the 100% is the original amount, which again, I have to add to. So again, if I notice now 125% plus 100% is going to be 225%, just in the same way that 1.25 plus 1 is going to be equal to 2.25, which means that 225% again is going to be equal to 2.25. Again, as if I could see that 225%, if I decimalize that from the get-go, again, to take that 225%, divide it by 100 to get 2.25, or move the decimal 2 spots to the left, 2 digits to the left to get 2.25. So what I can now do is now I'm just combining it, and I'm doing the 2.25 times the cans of corn to get the original amount. So all I've done is, again, making this just a little bit simpler. I'm just taking that percentage, adding it to 100%, and then multiplying it from that original amount to get my new amount. So my original was 240. I'm multiplying it by 2 times 2.25. So again, so the 2.25, which is the 100% plus the 125%, the 1 plus the 1.25 times the original amount of the cans of corn, which was 240. And again, that's how I'm going to get the 540. Now, by knowing this process, it's going to make some really difficult questions with a lot of steps a lot simpler. And one thing we do know about these timed exams is that if you can make them shorter and more straightforward, A, there's less steps, so of course it's quicker, and also there's less chances to make a mistake. So with percentages, again, it's always based on the original amount. So if I'm going for a percentage increase, like we had done before, I'm going to add that decimalized percentage. So before we took that 125%, decimalized it to 1.25, and added it to 1, and that gave us a 2.25. Now, if I want to do a percentage decrease, it's the same thing. The only difference is because it's a decrease instead of an increase, I'm just going to subtract that decimalized percentage from 1. I'm still going to multiply, because anytime I'm going from the original to the new, it's always going to be multiplication. The only difference is if it's a percentage increase, I'm going to add the decimalized percentage to 1. If it's a percentage decrease, I'm going to subtract the decimalized percentage from 1. But again, because I'm going from the original to the new, I'm always going to multiply. Unfortunately, you have a lot of questions on the SAT that, again, do things backwards. So what they're going to do is they're going to guess what the original one is based on the new amount. Okay, so a lot of students will take these numbers and just start multiplying because they think of percentages, when really that's what they got to do is divide. So for example, if I have a percentage increase, I'm still going to add the decimalized percentage. So whether a percentage increase, whether you're going from new to original or original to new, you're always adding the decimalized percentage to 1. However, since I'm going from the new to the original, instead of multiplying, since I'm doing the opposite, I'm going to the opposite of multiplication, which is divide. If I'm doing a percentage decrease, I'm still going to subtract. So percentage increase, I'm always adding the decimalized percentage. Percentage decrease, I'm always subtracting the decimalized percentage. However, again, since I'm going from the original to the new, which is the opposite of going from new to the original, I'm going to again do the opposite of multiplication, and I'm going to divide. So again, if I do an percentage increase, I add the decimalized percentage. If I do a percentage decrease, I subtract the decimalized percentage. If I'm going from original to new, I always multiply. If I'm going from new to original, I'm always going to divide. And if you keep it that simplistic, it's going to make some of these questions much more straightforward. So let's take a look at our next example. We have Katerina as the botanist, okay, and she has type A and type B pairs, and she knows it's a 20% increase from B to A, and eventually end up with 144 pairs. So let's kind of focus on our most important points here. We have type A and type B. We see 20% more than type B. So A was my original, B is my new. I'm sorry, B is the original, A is the new. Okay, and we also notice that type A has 144 pairs. And that's key here because a lot of students will just take 20% of the 144, and that's not how to solve this question correctly. So this particular question, what we're going to do is going to focus on the most important things. We know that A is an increase from B. So since A is an increase from B, think about what we're going to do. We also know that B is the original and A is the new. Okay? So again, they're asking us to go from the new to the original. So again, think about what we're going to do. So since we're going to increase, we're going to add the percentage. Since we're going from the new to the original, we're going to divide. And as long as you keep it that simplistic, it's going to make these very tricky questions much easier to handle. You're going to get them right, which is obviously the most important thing. And you can get them right very quickly, which is going to make a big, big difference in being able to get to other questions a lot faster. So, if we kind of focus on what the long way would be, we would take that B, we would take that original amount, and then increase it by the 20% of that original amount. Okay, so that was kind of the long way, kind of like that first way that we did that previous problem with the Kansas corn problem. But again, let's make this a little bit more straightforward. So again, A is an increase from B. So since it's an increase, I'm going to add the percentage. So I take that 100%, I'm going to add the 20%. Again, decimalizing it. So again, that's the 1, and I'm going to add the decimalization of 20%, which is going to be 0.2 or 0.20. And again, either way, I'm still going to end up with 1.2. Now, since I'm going from the new to the original, so again, new being the A, the original being B, I'm going to now divide. So I'm just going to take A, which is the one that I know, and divide it by 1.2. So again, an increase, I still add the percentage, new to original, I'm going to divide. So since I know that A is 144, I'm going to take 144 and divide it by 1.2, and that's going to give me my correct answer of 120. Again, if I want to focus on that long way of doing this question, if you look at it, I'm basically taking B, aka 1B, plus 0.2B is equal to A. It gives me 1.2B is equal to A. Guess what? Since they're giving me the A is 144, I'm still dividing by that 1.2. Again, it'll get you the right answer. Whatever gets you the right answer is the most important thing. But again, this is a much more simplistic way. Let's look at one more, a little bit more complicated. It puts a lot of what I'm talking about into play. Okay, and it just makes things just a little bit more straightforward. Okay, so we have a lot of moving parts in this question. So we have city X, we have city Y, we have a couple of years, we have a bunch of percentages, we have a bunch of numbers. Okay, so let's kind of just focus on the most important things here. So we have that city X and city Y were equal. Okay, we see that there was an increase of 20%. We see that there's also a decrease by 10%. Okay, so they're going to make this kind of complicated. So the population of city X is 120,000 in 2010. What was the population of city Y in 2010? Okay, so let's start with some of the things that we know. So in 2015, we know that X is equal to Y. Now, in 2010, we know that X is equal to 120,000. So what I'm now going to do is I have to figure out what I'm going to do with that 120,000, because that's the only figure, the only value, the only given that I have right now, besides the percentages increase and decrease. So since we're going to be increasing by 20%, and I'm going from the original to the new, so I'm going from 2010 to 2015. So again, because it's an increase, I'm going to add the percentage. Because I'm going from original to new, I'm going to multiply. So because I'm adding the percentage, again, I'm taking that 100% and I'm adding 20%. So again, by decimalize it, I'm taking that 1, same thing as 100%, and adding 0.2, the same thing as 20%, which is then going to give me 1.2. So that's my first step. Again, now my second step is, again, I'm going from original to new. So now I'm going to multiply. So I'm taking that original amount of 120,000 and I'm going to multiply it by 1.2 to give me 144,000. So again, increase, add the percentage, original to new, multiply. So what we're going to see with our next step is that we're now doing the reverse. Now we know in 2015 that X is equal to Y. So in 2015, Y is going to be equal to 144,000 since X is equal to 144,000. But now we have a decrease by 10%. And not only do we have a decrease by 10%, we have to go from 2015 back to 2010. So in this case, we're going from the new value in 2015 for Y, going back to the original value for 2010 for Y. So again, still think about that for a couple seconds. I'm going to be decreasing by percentage, so what do I need to do? I need to go from the new to the original. So what do I need to do? Well, again, from 2015, we're going from the new to the original. So again, the decrease, we're going to subtract the percentage. From new to the original, we're going to divide. So again, so 100% minus the 10%, that's going to be the same thing as 1 minus 0.1, or in this case, 0.9. Again, since I'm going from the new to the original, I'm going to divide. So I'm going to take that 144,000 and divide by 0.9, which is then going to give me the correct answer of 160,000. Okay, so just to make it a little more simpler on one little screen here, again, if I'm going to increase from the original to the new, I add the decimalized percentage to 1 and multiply. If I decrease from original to new, I subtract the decimalized percentage from 1 and multiply. If I'm going to increase from the new to the original, I'm still adding the percentage because it's an increase, but because I'm doing the opposite, I'm going to do the opposite of multiplication and divide. If I'm going to decrease from new to the original, again, I'm still subtracting that decimalized percentage because it's still a decrease, and I'm going to do that from 1. However, again, because I'm going from the new to the original, I'm going to divide. Okay, so I hope I tried to make this as simplistic as possible. Again, some of these tricky questions, even if you, it can be a little tricky, if you can at least know that there's a different way to approach these questions, at least you know that whether these questions can try to throw you off, that at least it's a new way of approaching it and a new way of looking at it. And then, unfortunately, not going to be quite as easy as you thought they are, but again, you can simplify it. Okay, so I did want to just talk about our Test Prep Time Plus. Again, just one little quick little plug here. Again, that's the one that we like to do. We do these ones that are a little bit more expanded at 1 p.m. Monday through Friday. So this one that we're going to do today, this afternoon, is on exponents, which a lot of students have some issues with. Exponents is a perfect example, just like percentages, of ones that seem really complicated, but there's some very simplistic ways of approaching it. Again, it's just trying to know how to approach these questions. Okay, my colleague Andrew Peterson did an excellent exponents lesson for the test prep time, the free one, a few weeks ago. So if you want to go back in the pages and look at the exponents that get a little basis, and then the one that we're going to do this afternoon is going to kind of expand on that. So the one earlier, a few weeks ago, will give you a good basis for the one today. I do want to talk about, again, the ACT at this point is still running on June 13th. So again, we're going to be teaching some online classes. We have one starting this coming Sunday, May 3rd. And then we're also going to be one due during the week. So the one on Sunday is going to run 1 to 4 p.m. online. All of our classes are recorded. So if you do miss a class, you can always catch up. And again, you can always review the material later. The one is going to be Mondays and Wednesdays, starts May 13th. That's going to run from 8 p.m. to 10 p.m. Of course, I do want to plug our online self-paced program. Again, now is the perfect time to start prepping for these exams, because we usually say it does take a few weeks. It's not something you can usually crash course for. So with this one, our self-paced program is based on an 18-week program. So starting now, you'd be very well prepared for, say, the August 29th SAT, the September ACT. Really prep you well. Again, we do like to say 15 minutes a day, and you can really increase your scores. Again, I would take advantage of the discount that's currently offered. That won't be out there forever, so take advantage of it now. So again, it's normally $199, but if you use the offer code of FUTURE, it will cost $99.50. And then finally, I would certainly subscribe to our blog. As we have seen, many things have changed rapidly. Hopefully, things will start opening up. Hopefully, we'll have some more concrete news on all the exams and how they're upcoming. Ones that will be in person, ones that may be online, ones that are still running, ones that hopefully will not, but it's certainly possible could get canceled. So by subscribing to our blog, you can stay up to date on the webinars that we'll be doing. So certainly on our Facebook page, our Instagram page, LinkedIn, or Twitter, or any or all of the above. Again, we hope you find these are beneficial. And our test prep time clubs at 1 p.m. Hope you have a wonderful day and you're all staying safe. Have a great day.